Today we're going to start Spark. All right. And there must be some people out here who's probably joining my class for the first time. They're all coming from data science. Hey, everyone. And I don't know if you guys know me. My name is Dr. Krish, and I'm the founder, CEO of Browse Jobs. And I hope you like my way of teaching. And we're going to have fun. Okay. Now, first of all, what is Spark? All right. And one request from everyone who's joining here for the first time, please talk to me. All right. I like this to be very conversational. I like this to be very interactive. So ask me if you don't understand, stop me. Don't wait till the end of the class. Just stop me then and there and ask me questions. All right. Now, so what is Spark? All right. Now, Spark is like an engine. All right. Imagine you have your car. All right. Now, the speed of the car depends on the size of the engine. You must have heard of something called CC. Right. So, Spark is like that. All right. So, Spark is nothing but an engine which is used to transform and process the data, like to see, at the end of the day, our job is to clean the data. All right. Now, if we get too much data, then we need something very powerful to clean that data. Correct. Now we also have Pandas. Now Pandas is used to clean a small amount of data. All right. And Spark is used to clean large amounts of data. All right. Now, why is Pandas used to clean small amount of data? Because Pandas does not work on distributed system. Now, what is distributed system? I'll explain. Okay. Now, like I said, the bigger the engine, the more faster the car. Correct. So if I have, let's say, if I'm carrying one person in my, let's say I have only one passenger, then I can pick up a small scooter or a bike and I can drive them around based on the power that the engine of the bike is. Now, if I have 5 people, then I will get a car and I'll drive them around in a car which is sufficient to carry 5 people. Now, if I have 50 people, all right, I cannot drive them in a car. I need something more powerful to drive them around. All right. Now, for that, we need some bigger engine, like a bus engine or like a whatever, bigger engine to travel with those 50 people. Now, similarly, if I have up to, let's say, 500 MB or 1 GB data, then I can use, Pandas. And when we use Pandas to transform data, the transformation happens on our system only. All right. It is and if you know your system, you will have one memory, like, one processor. You'll have memory. You'll have 16 GB memory or 8 GB memory, which is RAM. All right. So that is sufficient to transform your data on your own system. What if I have 100 GB or 1 terabyte data? Then I need a lot more space a lot more power to transform this data because we have a lot of data coming in. Correct. So in those scenarios, we use something called distributed network. Now, what is distributed network? Okay. Now, let's say you are running a restaurant. Okay. Now you have, let's say, Rameshwaram. Okay. In Rameshwaram, you have a chef, and this chef can make 10 dosas per hour. Okay. Now, suddenly, some guy comes and he says, boss, I want 100 dosas. All right. Now, if a chef can make 10 dosas per hour, how many hours does he need to make 100 dosas?
10 hours.
10 hours. 10
10
hours.
hours.
10 hours.
Correct.
10 hours.
Now, do you think the customer will wait for 10 hours?
No, sir.
No, no, sir.
No.
He won't wait. He'll be angry and he'll be like, what the hell? Why are you taking so long? And he'll cancel the order. Similarly, all right. So if I have to make 100 dosas now, what options do I have? All
You
right.
can hire 10 more chefs.
And more chefs.
Correct. Correct. So now if I say these chefs are my workers, okay, they are my workers. Okay. So I am hiring 10 more workers to do 100 dosas. Now, what happens if I hire 10 more workers? Each worker will get 10 dosas and they will work in parallel. So we are distributing the work to the 10 chefs, all right, to make those dosas. Now we can make 100 dosas in 1 hour because I have 10 workers to do that. Correct. This is what distributed computing is, which means we will add more workers. Okay, we will add more workers to transform or work on that data. If we get more data, we will add more workers. And each worker will have his own node. Node means computer. Okay, node means computer. Now, virtual computer. We call it Java virtual machines. Now, what is this Java virtual machine? Imagine your laptop, but without keyboard, without screen, without nothing, except only the processing power. You understood? It'll have memory, it'll have RAM, it'll have processor, all that it'll have, but it won't have mouse, or it will not have. That is why it is called virtual. All right. So we'll add more nodes to compute this data. This is what distributed computing it means. You understood? Now, in Spark, we have this is a guaranteed interview question, guys. So in Spark, we have an architecture. How does Spark work? What is the components of Spark? So Spark uses something called master and slave architecture. What do you mean by master and slave? So let's say you have an employee in your office or in your restaurant, and you are the master and there is workers. A slave is a very not a right word to use, but the name of the architecture is called master slave. All right. So imagine you have workers. All right. Now what happens if you have workers? So master will get the requirement. So when I go to the restaurant, I will not go directly to the chef and tell him, boss, can you make 100 dosas? No. Who will I tell it to? I will tell it to the manager of the hotel, or I will tell it to the cashier or the owner of the hotel. I need 100 dosas. All right. He is the master. Correct. Now, what does this master do? He knows I have only one chef inside. So what he'll do is he will plan. He will create something called a logical plan. What do you mean by logical plan? He will plan, okay, boss, I need to make 100 dosas in the next 1 hour. So I need to bring in 10 more workers and I need to bring extra ingredients. Like I need to get more dosa batter. I need to get more chutney. I need to get more oil. I need to get more ghee. I need to get more aloo. He will plan all that. He will make a logical plan. Who will make? The master will make. Okay.
Master.
Then he, then he will call the manager, the hotel manager, restaurant manager. He will say, oh, darling, come here. Okay. Look, this guy wants 100 dosas. This is my plan. Can you go add more, go allocate all the resources to the workers and make them execute the dosas. Whose job is that? That is the job of the manager. Correct. The owner is planning. He will create a plan. He will take the order. He will create the plan and he will interact with the manager and he will tell him, darling, you go allocate 10 workers. And with the 10 workers, you give them whatever they need. So they need stove, they need gas, they need batter, they need oil, they need ghee. All right. All that you keep allocating to those workers. Then you make them work. So the workers will start making the dosa. And once they finish making the dosa, they will not give it back to the manager. They will give it to the owner. You understood? So once it is done, all that finished product is sent to the owner. So the owner will give it to the customer. You understood?
Yes.
Yes, sir.
Yes, sir.
So
Yes, sir.
this is your architecture. That's all.
Yes, sir.
So the name of the owner is called driver program. The name of the manager is called cluster manager. And the name of the worker is called worker nodes. That's all. Easy peasy.
Yes,
Yes,
sir.
sir. Yes, sir. Yes.
Any doubts? Questions?
Sir, as we see the diagram, there are some questions.
Yeah. So he is the owner, driver program.
Yes.
He is interacting with the cluster manager.
Yes, sir.
And he will allocate the resource to the worker nodes. And once the execution is finished, he will send back the dosas to the driver program. You understood?
Yeah.
Yeah. Now,
Got it. Got it.
okay. Now, the dosa here is nothing but your data. Okay. And the making of the dosa is nothing but cleaning your data. And allocating the resources, nothing but allocating memory, allocating number of executors, all that is allocating resources. We'll go to that in depth. Don't worry about it. Okay. But on a high level, you understood who is the owner, who is the manager, who is the worker. Okay. Now it also has something called Spark context and Spark session. So Spark, before Spark 2.0 version, okay, it used to be called Spark context. Now, what is Spark context or Spark session? It is nothing but the entry into Spark. It is nothing but the entrance gate into your restaurant, into Spark. Because only if I enter can I place the order. Correct. Only if I enter, I can ask the driver program to do something. That is what your Spark context is. Now, after Spark 2.0 version, all right, it was called, they started calling it Spark session.
Session.
Okay, they made some upgrades and they started calling it Spark session. Okay, now, okay. Now, what was the other main difference between Spark context and Spark session? All right. When Spark session, what they did was, see, in Spark, we can use Python as an API and we can write PySpark code. All right. Then we can also write SQL. That is why it is called Spark SQL as well. We can write normal SQL code and make it execute as well. So they had different entry points for different things in Spark context. But in Spark session, they brought it all together and they made only one door. Got it? Before they had multiple doors. If I have to do Spark's context, Spark, what do you call, SQL, I had a different door. If I had Python, I had a different door. All right. Now they made a single entry point in Spark session. That's all. That is the only difference between them. Got it? Any
Yes,
doubt?
sir. No, sir.
All right. Awesome. Okay. Now we have 7 steps. So in your interview, I will explain how to explain your code and explain your architecture in your interview. Now, why am I explaining this for you? Okay, whatever I told was good enough now, sir. Why extra fittings you're giving me? All right. See, my guys have to be the best in the market. Okay. We cannot compromise on quality. Now, a lot of people come and tell me, sir, I'm sitting in interviews, I'm not able to crack the interviews. Obviously not, because you're not following what I'm asking you to follow. Why? Now, can you imagine, all right, every company, when they do interviews, will they interview only one person? No.
No.
No, sir.
No.
No, sir.
No.
They will
No, sir.
interview at least 4 or 5 people. Now, don't you think we have to be the best amongst those 4 or 5 people? Only then we will get an opportunity. What if, so let's say we are about 60, 70 people in this class, right? Now, in this 70 people, 50 people will follow what I ask them to follow. They will do exactly what I ask them to do, like the way I'm explaining now. The remaining 20 people will say, no, sir, I will tell it in my own way because it is difficult for me to by heart or to remember it. All right. Now, let's say there are 10 positions and all of you guys are sitting for the same interviews. Obviously, the preference will be given to the person who's following my instruction. Now, why is my instruction so perfect? There's some background noise, Ramesh. All right. So why is my instruction so perfect? I know exactly what to say in every interview that will give us the the advantage over other candidates. Why? Because I don't know anybody who's attended 15,000 interviews. I have physically sat in 15,000 interviews and collected data. Even now, my guys, we hired 2 people just to sit in interviews and collect data. Why? If I don't have the data, how can I guarantee that you will crack your interviews? I cannot. That's a lie. I'm not here to deliver content and say goodbye to you guys. I'm here to make sure you are equipped the best of the knowledge so nobody else gets a chance. Now, why have I broken this introduction of Spark architecture into 7 steps? Now, what is the secret of an interview? Let me explain. The secret of cracking an interview is to answer questions even before they ask the question. How, sir? How is it possible that we can answer questions even before they ask the question? Very simple. Now, if someone comes and asks you, okay, if let's say you're meeting someone for the first time, all right, let's say you go on a date. Okay, let me just give me 1 second. All right, let's say you go on a date with, okay, now how do we make sure we get perfect answer for every interview that we attend? Okay, let's say you go for a date. All right, now first date, now you don't know that girl. All right, so you go and you introduce yourself. All right, now you say, hi, my name is Krish, and she says, hi, my name is I'm scared to say anybody's name, but let's say some
Or you can say your wife name.
let's say my name.
Why are you searching other names?
Ramesh,
Yeah.
seriously, man, I thought you'll be in support of me. I thought you'll say, sir, they say Deepika Padukone or something. Huh?
Can
Even,
use Sukruti, sir. This kind of.
even in my imagination, I should use my wife's name only. Yeah.
Yes, sir.
Oh.
Yeah.
Okay.
No, you can use Sukruti or different kind of name, sir. No
I
problem.
know. No, I will use Deepika Padukone. You have a problem?
Oh, no, I don't have.
Who is jealous?
Sir, take Tamanna's name.
Take Tamanna. I'll take Tamanna. Okay. So let me say I go for a date with Tamanna. Okay. I say, hi, my name is Krish. And she says, hi, my name is Tamanna. Now, what will be the next question that you think she'll ask? Okay, what do you do? Where are you from? Right. Now, for everything, if I'm giving only one word answer, let's say she says, where are you from? I say, Bangalore. And then she says, what do you do? Engineer. I mean, then tell me about your family. Oh, 4 people. Array, expand, man.
Like Maniratna movies, sir.
Expand. You should give more information, give them all the information that they need so that they understand you, right? So that is exactly what interview is. You should never give them one word answers. You should always expand on your answers. You have 30 minutes in your interview. That 30 minutes is yours to showcase your knowledge. Got it? It is a place where you can, 30 minutes, let me give them whatever knowledge I have. He is not going to sit there and baby, tell me more about yourself. Baby, what is Spark architecture? Baby, what happens in step 1? Baby, what happens in step 2? No. Baby will not be patient. He'll get irritated. So what do we need to do? The minute he says Spark architecture, I will tell him exactly how that Spark architecture works from start to finish, including background information. Got it? Now, what have we done? We've avoided at least 5-6 questions. Correct. That is the major advantage of applying my technique on how to explain your question in your interviews. If you wait for them to ask questions, that will irritate them. Now, he's got 30 minutes. He's got to ask, let's say, at least 10 questions in Spark to check your knowledge. Now, if all 10 questions is only about architecture, don't you think he'll get irritated? Now, he doesn't know how much you know about the rest of the things. So what will happen? He's getting pissed off. You got it? So for that, we use a 7-point techniques. Okay. Now, how do we answer Spark architecture? Number 1. All right. We start with the driver program. Who is a driver program? Driver program is your owner of the restaurant.
Owner.
Correct.
Owner.
He's the owner of the restaurant. Now, when I go give him an order, all right, to make 100 dosas, what is he first going to do? He will check the order. What is the exact order? Is it masala dosa, khali dosa, paper dosa, whatever dosa? He will check the order. So Spark driver program will check your code. He will read your code. All right. Then what he will do? He will create the entry point, the Spark session or the Spark context, depending on the version you're using. All right. Then the minute he's read the code and he's created the session, he will call the manager of the hotel. Who is that? Your cluster manager. He'll say,
Cluster.
correct. He'll say, come here, darling. I want to give you this order. And he will start building connection with the cluster manager now. That is step 1. Step 2, he will convert that order that you gave, that 100 dosa order, he will convert it into a logical plan. He will start planning. Okay, how many workers do I need? How much memory do I need? What should I do first? Should I put ghee first or should I put the batter first on the plate, on the, on the tawa? All right, what should I put next? Should I put aloo next or should I put chutney next? So he will create a perfect plan to execute those 100 dosas, which is nothing but your code execution. He will check, should I import the data first or should I start transforming first? Should I remove duplicates first or should I fill null values first? Should I do joins first or should I do this first? He will create a perfect logical plan. Understood? Then he will start optimizing the steps in your code. All right, what he'll do, he'll remove all unnecessary steps because you might have added some unnecessary steps in there. So he'll start removing unnecessary steps and he will rearrange your code, which is nothing but optimizing. Why optimize? Because I want to get perfect output in the fastest way possible. So what will I do? I will start optimizing my plan or my steps that you've submitted. Then he creates something called a DAG. Now, DAG stands for Directed Acyclic Graph. What is this directed acyclic graph? I don't know why they gave that name, but let's keep it. You will get it. Don't worry. Directed acyclic graph means that plan that you've created, the logical plan, it will be created into tasks, separate steps and tasks. Task 1, task 2, task 3. He will start creating that. Got it? Now, once this is created, we will break the DAG into stages. Okay, stage 1, let's make the dosa. Stage 2, let's add masala to it. Stage 3. So it will break it down into stages. Okay. Then after all this is done, he will give this to the cluster manager. Who is the restaurant manager? And he will tell, darling, I've given you this. Can you please go give them all the resources that they need so they can start executing this 100 dosas? You understood? Now, once he goes and gives this to the cluster manager, he will go and he'll give the workers, boss, how much gas do you need? How much ghee do you need? How much batter do you need? He will start allocating resources. How much memory do you need? How many executors do you need? How much processors do you need? How much cores do you need? He will start allocating. And finally, once this is done, the execution of the code starts by the executor. And once the execution is finished, the driver program will stitch all the data back, because the data is just, see, 100 dosas was one order, but we divided that into 10 orders with 10 people. Now, when I'm giving back it to the customer, I cannot give him, okay, first 10, second 10. No, I have to collect all the 100 orders together and then give it back to the customer. And that the driver program will do, where he will collect everything together and give it to the who?
Driver program.
Driver program.
Customer.
Driver program will do it, but who will
To
it
the user.
Customer.
customer? In your case, to you. You are the user, because you are the one who requested, right? So this is how you need to explain your code in 7 steps, or not code, your architecture. So now, don't you think when you explain this, you know exactly how the architect Spark is working, the engine is working?
Yes, sir.
Yes, sir. Yes, sir.
Do you think
Yes,
that
sir.
guy will be impressed?
Yes, sir.
Yeah. Yes,
That's
sir.
it.
Yes, sir.
That's it. Got it?
Sir, what is this white transformation here?
We'll come to that, darling. I'll tell you. Okay, we'll come to that. Awesome. So this is how we explain Spark architecture. Got it? 7 steps. We have something called memory cards. I'll give you those memory cards. Print it, stick it to your laptop. When we do our question answer mock interviews, I'll give you that. Okay, stick it to your laptop, and just, if you remember my restaurant example, you will remember everything. Correct?
Yes, sir. Yes,
That's
sir.
That's all. This is how you explain your Spark architecture to your
Spark
interview.
architecture.
Okay. Any doubts here, guys?
No, sir.
Easy peasy. It is a guaranteed interview question. So in Spark, you will get about 7 to 10 questions. This is one question guaranteed. Okay. All right. Now Spark has a data, what do you call a data type? Like, in list, we have list, we have tuple. In Python, we have list, tuple. Okay. So like Python has list, tuple, dictionary, and set.
Dictionary set.
Spark also has a default data type, and it is called RDD. RDD stands for Resilient Distributed Data Set. Okay. Now, what is the features of this? Like I told you, like my son's first girlfriend list, he is ordered, allows duplicates. He also is mutable, is changeable. Correct. His girlfriend also is acceptable. She's changeable, right? So similarly, in Spark also, it has some features in RDD. The number one feature is it is immutable. What does immutable mean?
Not changeable.
Not allowed. Changeable.
Changeable. Okay. It also has a second feature called fault tolerance. Now, what is fault tolerant? The name suggests what? Fault, tolerate the faultiness, which means if I fail when I'm processing the data, if I fail, I am saying, please tolerate me, which means when you start again, it will start from where you last stopped, which means you will not be losing data. Got it? So fault tolerant means it will start from where the transformation failed. Okay. Then third feature is called lazy evaluation. We learned lazy evaluation somewhere else. Do you remember in Python? Do you remember generators?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Correct.
Generators.
Correct. Similarly, here we have lazy evaluation. What does lazy evaluation mean? So it means that the transformation that you're submitting, which is the removing duplicates or removing null values, all that, it will not start until an action is called. Now, what does this mean? I'll explain what transformation and actions are, but I'll give you a simple example. Now, when people are standing in a running race, okay, everybody say, Anima, get set, go. So that guy will not start running until he calls go. Correct? So same way in Spark, we have something called an action. So the transformations will not run, even if you write 100 lines of code. It will not get executed until we say go. The word is not go. There are some action words which I'll tell you. For example, collect or count or save. Got it? And transformations are nothing but join, drop duplicates, filter, map. All these transformations will not run until the action word go, save or count or collect is called in the end. You understood?
Yes, sir.
So these are three primary features of RDD. We also have something called in-memory computation. What does that mean? So RDDs are stored in memory by default. Memory means your RAM memory, right? Which means it is very fast to run these transformations because it is running on memory only. And finally, it supports parallel processing. What does that mean? Which means the data is split into small portions, partitions, like your workers. All right. And each portion or partition is run separately, parallelly, which means they're all running together. So it is not waiting for one guy to finish so that the other guy starts. They're all running together. So it supports parallel processing. So these are the 5 primary features of RDD. You understood, guys?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
All right. So what is the default data type of Spark?
RDD.
RD.
Correct. Correct. Super duper. Okay. Now, in transformation, guys, the new guys, are you guys understanding? Any doubts? I teach like this only, darlings, with a lot of stories. So hope you guys are coping. All good so far?
Yes, sir.
Yes, sir.
Awesome. All right. Okay. Now, in transformation, okay, in transformations, what do you mean by transformation? We are changing the data to do something. For example, if there are duplicates, we are dropping duplicates. If there is some data, we are filtering out data. If there is null values, I'm filling null values or dropping null values. I'm removing those null values. All right. So we are running some aggregations. So all this come under transformations. Okay. Now in transformation only, there are 2 types of transformations. Okay. Let me explain this here. All right. There are 2 types of transformation. One is called narrow, another one is called wide. Okay. Now, as the name suggests, all right, wide means, is it covering more space or less space?
More.
More.
More space.
Narrow means covering less space. Correct.
Yes.
Yes.
All right. So I already told you we are creating multiple workers. Okay, I'm creating multiple workers to execute the data. All right. Let's say I submit customer data. All right. I am importing customer data into Spark. All right. To do some transformation on customer data. Now, customer data has customer ID, customer name, address, phone number, age, whatever, data of customer. Okay. So this data has, let's say we have like 100 lines of data. Okay, let's say 100 is big number. Okay, for now, let's assume 100. Okay, we have a large amount of data. All right. So when I import, what happens? The data gets distributed between the workers, between the chefs. Correct. So from ID number 1 to ID number 20, it will go to worker A. From 20 to 40, it will go to worker B. 40 to 60, it will go to worker C. 60 to 80, it will go here. And 80 to 100, one more worker is there. Okay. So each worker is getting some data. And it is divided between those workers as evenly as possible. It will not be exactly even, but as evenly as possible. Okay. Now we are dividing this data between those 5 workers. Okay. Now let's say I bring in one more table called sales table. Now I want to find out how many sales was done by each customer, total sales by customer. How can I do it? Oi, no, darling, listen to me. Okay. Customer data is, we got 100 customers. You remember customer table, employee table? Yeah.
Yes, sir.
Sir.
So we have
Yes,
only
sir.
we have only customer data inside that. We don't have sales data. Correct. Now I have sales table that I bring. I import sales table. And sales table will also get distributed between those workers. Okay. Now, how can I tell how much total amount of sales done by customer? I have to join these two tables, yes or no?
Yes.
Yes, sir.
Yes.
How will I join them? Primary key and
Primary key, foreign key.
Primary key.
Primary key.
Primary key. Foreign
most
key.
probably will be
Foreign key.
most probably will be joining on customer ID. Correct?
Yes, sir. Yes, sir.
Yes, sir.
All right, good. Now, when I join them based on customer ID, all right, let's say customer ID 1 to 20 is here. Okay. 2 to 20 to 40 is here, 40 to 60 here, 60 to 80 here, 80 to 100 here. Okay. But when I import sales table, do you think the foreign key from 1 to 20 will be here only?
No.
No, sir.
No.
It can be anywhere. No, because we are distributing based on ID column, sales ID column. So customer ID can be, customer ID 1 can be here or here or here or here. Yes or no from sales table?
Yes.
Yes, sir.
Yes.
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 So if I join those two tables based on ID column, then don't you think some data like ID 1, if I'm joining ID 1, let's say ID 1 foreign key is here, don't you think this data should go here to join? Or this data should come here to join? Because they're all separate computers. You remember? They're all separate JVMs. So don't you think the data should the data should move around between them to join those tables?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Correct. This process of moving data from one node to another is called shuffling. Okay, it is called shuffling. So when we do certain transformations, all right, when we do certain transformations, the data moves from one node to another, or from here to here, or here to here, or here to here, here to here. For example, join, or if I do group by, if I do distinct. So there's a movement of data between the nodes. All right. This movement of data causes shuffling. Okay, which means, okay, I'll remember this. Okay, shuffling. Let me go back to the restaurant now. Okay, now the 10 chefs are making dosa. Okay, but there's only one ghee bottle. You understood? There's only one
Yeah.
ghee bottle.
Yes,
and that
sir.
ghee bottle is sitting in the middle. Now all the 10 people are making dosas. So that ghee bottle will get shuffled between 5 workers, 10 workers? Yes or no?
10 workers.
Yes, sir.
Yes, sir.
Yes, sir.
So, do you think while shuffling this, do you think this will take more time?
Yes,
Yes, sir.
Sir.
Correct. So shuffling means when the data is moving from here to here, that means that movement also needs some energy. It needs some space. Correct. So if it is moving from here to here or from here to here, it needs some energy, it needs some memory, and it needs time as well to move, which means shuffling will delay the process to a certain extent. But we cannot avoid shuffling full, like, because joins will cause shuffling, group by will cause shuffling, and we cannot transform without joins, group by, or distinct. We know that. All right. Which means shuffle will happen, but it will also take extra memory, take extra space, and extra time. Which means shuffling is not a good thing, but we cannot avoid it. But wherever you can avoid, you should avoid. If you can avoid it, avoid it. All right. But most of the times, most of the scenarios, we cannot avoid. We have to use joins. All right. So this shuffling, when the data is shuffled between nodes, it is called wide transformation because the data is moved wide in a wider way. Whenever transformation is happening without shuffling within the JVM, within the node, without moving the data from here to here or here to here or here to here, there are some transformations where shuffle will not happen. For example, map or filter. In these scenarios, the shuffling does not happen. So in those scenarios, these kind of shufflings are called, these kind of transformations are called narrow transformations. You understood?
Yes, sir.
Yes, sir.
So this is narrow and wide transformation. Got it? So like I said, we cannot 100% avoid it, but wherever we can avoid it, avoid it. You got it?
Yes, sir.
Yes, sir.
Got it.
Awesome. Now, anybody has a doubt on this? The new guys, the old guys, any doubts on narrow and wide transformation? Or ask me any silly doubt, no problem. It's okay. But I wanted to understand because these are all interview questions. Difference between narrow and wide is an interview question. All right. What is RDD is an interview question. I don't teach anything that we don't need for our job or our interview. I don't follow textbooks. I follow the data from that 15,000 interviews. Got it? So if you're holding a textbook in your hand, sir, they've told something else over here. I don't care. You tell what I told in the interview, you will get a kiss on your cheek. Guaranteed. Virtual kiss, JVM kiss. You got it? Any doubts, guys?
No.
No, sir.
No.
Easy peasy?
Yes.
Yes, sir.
Okay. So we already learned 3 out of 10 questions in PySpark. Guaranteed questions, guys. There's no doubt about it. Okay. All right. Now, I spoke about staging. You remember when the driver program creates the DAG, divides the DAG into stages.
Yes, sir.
Correct?
Yes, sir.
Yes, sir.
Now, first, it will divide it based on narrow and wide, and that narrow and wide will be divided, grouped into stages. All right. So it is just organizing your code in a nice way so that it executes as fast as possible. And it is all automatically done. You don't do anything. You submit the code. That's it. We have something called Spark submit. All right. The rest, it is done automatically. So you don't have to scratch your head on it. Okay. Now, how does it divide it into stages? Very, very simple. All right. The first stage, let's say this is my first stage, stage 0. Okay. it'll be your narrow transformation. Okay, it'll hold your narrow transformation. The minute we add the minute the next transformation is a wide transformation, the minute there is movement of data from one node to another, it will automatically divide that into a new stage. Okay, it'll divide that into a new stage. Then after that wide, let's say there are two more narrows, then it will not divide. That narrow will happen in the same stage. But after the two narrows, let's say there was another wide. Okay, that will divide it into a new stage. So at every wide transformation, it will divide it into a new stage. Got it?
Yes.
Any doubts?
No, sir.
No, sir.
Very-
No,
So
sir.
every time there is shuffling, it will break it into a new stage. That's all. Nothing that as simple as that. It'll start with narrows, stage 0. Then let's say we have narrow, 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 and then suddenly it has a wide. So wide means it is shuffling. So suddenly it'll move that data into it'll split that into my new stage. Then again it has narrow. So it'll happen in the same stage. Narrow, 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 narrow. Then suddenly another wide, it'll split that into a new stage. Got it? So this is how stages are created inside your DAG. Okay. DAG is nothing but collection of tasks. All the tasks you're submitting, narrow, wide, whatever, it collects them and it orders them in a way and it splits them into stages so that it is very nicely executed without any delays. It will automatically do it as much as possible to make it run faster. Okay, but then sometimes it says, boss, I've done it, but still there is some delays. Can you do something else to make it run faster? All right, that is when we come and we optimize it more further. You understood?
Yes, sir.
Yes, sir.
Okay. So the 7 steps are here. Spark initialization, it will parse means it will read your code and create a logical plan. Then stage splitting in the DAGs, then pipeline the stages. Then I will explain what this predicate push down and task scheduling and task execution is. All this is happening inside your driver program only. All right. Then finally, your cluster manager will allocate resources. Then this guy will execute and it will return the results to your driver program. Now, what is these middle steps? Okay, that happens while creating your logical plan. Okay, while within your driver program, it is happening inside. Now, what is this and why are we doing this? It is exactly what we learned in SQL, nothing different. Okay. Don't worry about all these. This is just simple breakdown. Okay. I will explain what those optimization steps at a later stage, but let's go to our cluster manager. Okay. Now our cluster manager has different modes of execution. Okay. We have different modes of execution. All right. The first mode of execution is local mode. Local means it is running only on a single machine. Okay. It is not distributed. Okay. So that means we very rarely, and if you're using this, we might as well use Pandas. We don't need Spark for that. So this is not something that is commonly used. Then we have client mode. Client mode means the driver program will run on the local machine and the rest is running on a group of the work. So for example, the driver program will have a separate computer, a local machine, and the workers will have separate clusters. Cluster means collection of nodes, collection of computers. Okay. So for example, these are clusters here. So this is a cluster. It's a collection of computers, collection of nodes. Okay. So this also very rarely we use this. And again, it has a very unique use case. So we don't need to scratch our head on that. Okay. But what we use on a day-to-day basis is this guy. It's just cluster mode, which means we are working on with multiple machines to handle our data. That is what we use. Okay. Even with this cluster mode, there are different types of cluster modes. The first one is standalone. Now, we don't normally use standalone because it is mainly used with testing. When you're testing, before you launch the car on the road, you have a test case. You will take it to a test center and you're testing how that car runs. Okay, so that is your standalone mode. So we mainly use it for testing our application, Spark application. Okay, then we have something called yarn. This is what we use. Okay, they might ask which cluster mode did you use? We used yarn. That's all. Now, what is yarn? Yarn means yet another resource negotiator. What does that mean? It means it is another resource negotiation engine. So someone could not find a good name, so they named it yarn. Okay, this is running on another big data framework called Hadoop. So Hadoop is a big data framework which was introduced in early 2010s and 11, 12. You must have seen everywhere an elephant picture. Okay, come learn big data, come learn Hadoop. All right, back then it was quite popular. Now everybody's using Spark. Okay, so this yarn is built on top of this framework called Hadoop. They used Hadoop and they built it on top of that. Okay, so they borrowed some features of Hadoop. When do we use yarn? When we are working with large amounts of data, which is why we are using Spark. Correct. So when we are working with exabytes, terabytes, petabytes of data, mainly when we are using it in production, that is when we use yarn.
Yeah.
Okay. Then we have something called Kubernetes. Has anyone heard of Kubernetes before?
Yes, sir.
In DevOps.
Yes, sir.
Yes.
Yes, sir.
What is Kubernetes?
Container.
Container.
Okay.
Manage the containers.
Containers.
Correct. Now, you remember I told you JVM. Okay. Each JVM is processing some data. Okay. Now we have another framework called Dockers. Dockers is nothing but it's containerization. So what we do is, if you go to Facebook, okay, Facebook has Messenger, Facebook has what do you call marketplace, Facebook has games. All right, so it has different applications inside. All right, so this also, okay, each app inside Facebook is put inside a container. It is not a single application. Everything is working inside a container. Each application is working inside a separate container. Now, why are we doing this, sir? What is the use of this? Okay, let's say some guy working in game section, he does something to the code and everything goes down. Okay, now when something goes down in the game section, all right, now which part of the app will go down? Only the games app, because it is in a separate container. Similarly, if someone messes up with messaging, only Messenger will go down, but the rest of the applications are running properly because it is put into different containers. All right, so when we are using Docker or some sort of containerization technology to process our data, all right, then we use Kubernetes. And the reason we use Kubernetes is Kubernetes will orchestrate these containers. What do you mean by orchestration? It will say, oh, you execute first, you execute next, you execute third. All right, it is like, that orchestra where there's one guy standing in front and he's with a stick and he's telling, okay, flute, you play now. Okay, piano, you play now. So Kubernetes is that guy who's orchestrating these containers. Okay, now we will only use this when we are using a technology like Docker to containerize our Spark application. So if you're using multiple Sparks, all right, then we will containerize each application into each container and we will run it. And for that orchestration, we need Kubernetes. It is out of syllabus for us. We don't need to scratch our head. You just need to know what it is. Then finally, we have Mesos. Mesos means we have processing data, but we have limitations on how much memory we can allocate because memory is money. So the manager will come and say, boss, we need to carefully monitor this because we don't have budget. So when we have to carefully monitor our work, then we use Mesos. All right. But for us, we only focus on this guy, Yarn. And they won't ask anything more than this. You will not have to scratch your head. Even in your real world, 99.99999% you will only be using Yarn. I have never seen a project where we've worked on Kubernetes or Mesos or standalone, but it has those options if you need. That is all you need to know. What are the different types of modes of execution? We have local mode, cluster mode, and client mode. And within cluster mode, we have standalone, we have Yarn, we have Kubernetes, we have Mesos. That's all. And they don't really ask this question, very rarely, but they can ask. You understood, guys?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
So we don't have to explain the standalone and yarn all. We just have to tell the names, right?
If you can explain, I told you,
Brownie points.
you will get
Yeah.
virtual
Brownie
kisses,
points.
brownie points and virtual kisses if you can. All right. See, I know we will try to avoid as much as possible, but if you can do it, don't you think he will be like, wow, nobody told this girl told.
Yeah.
Do you think, let's say there's a 7-year experienced data engineer who goes for an interview, do you think he will talk about all these when he's
No.
not using it?
No, sir.
Never. Impossible. Unless he goes and studies the textbook. And now who will remember even after studying the textbook? He can only explain what he has done. But we are learning with respect to cracking the interview, which means we will know every answer and we will know every answer in depth. Correct?
Yes.
Yes, sir.
That means even if you are a fresher and more for a fresher, all right, if you can explain this, boss, 100 virtual cases, I will take a bet no bloody fresher in the entire country will be able to explain this. Open challenge. I've attended so many interviews that I know exactly what they can answer. They can answer only, one-line answers and they'll expect to get a job. Now imagine my guys and go tell, oh, modes of execution, no problem, sir. There are 3 primary modes, local modes, cluster mode, client mode. In local mode, it is predominantly run on a single machine. Cluster mode is a collection of machines and client mode is where the driver program is sitting on one in the local machine and the rest of it is running on a cluster. So within the cluster mode, we have 4 types of clusters. We have the standalone, we have Yarn, we have Kubernetes, and we have Mesos. In standalone, we primarily use this for testing purposes.
ST.
All right. And Yarn is mainly used for large, which is what we used in our projects. So we used Yarn because we were handling exabytes and terabytes of data, which is primarily meant for production purposes. And Kubernetes, we didn't predominantly use because it was primarily used for containerization. When we use containerization, and Mesos is when we're actually using closely monitoring our usage of data. In those scenarios, we use Mesos. So that way, when this guy explains this like this, pakka 100 virtual cases. I can give you a live example. There was a fresher he was doing an interview for ZS Associates, Pune. All right. And I'm not lying. Okay. He answered this in the same way. Okay. And he stopped the interview after that. This was like his fifth or sixth question in the interview. He stopped the interview and he asked him, which college did you go to? And he told whatever college. And he said, did you like work in a live project and things like that? He said, yes, sir, I've worked in a live project. And he said, how the hell do you know all these? He said, no, sir, I'm just well prepared for the interview. I just went through the syllabus and I came well prepared. That guy was like, I've taken hundreds of interviews and nobody answered the way you did. All right, I think we should conclude this interview. And when can you join us? I swear on God, this is exactly what happened in that interview. If you don't believe me, you try it out and let me know. That is why I beg people, please take notes or watch my videos and write it down. I will also give you notes. See, my notes, I cannot talk about dosa, idli, and sambar. That is my way of explaining it. But you can write it down while I'm teaching, right? My notes will be mostly, the textbook notes, right? But write it down, all right? Trust me, you will have a smile on your face when you come out of that interview. Nobody can beat you in this if you follow my instructions. Got it?
Yes, sir.
Yes, sir.
All right. So we've already done narrow and wide, so I'm not going to go into this. These are my thing. This also, I will explain this at a later stage, how the allocation of the data happens and how the allocation of thing happens. Now we're coming to AQE and Catalyst Optimizer, and I will take this up in the next session, guys. This is optimization techniques. Okay. Awesome. All right. Any questions so
Okay,
far?
sir.
Any doubts? Anything that you guys want to ask me?
Sir, can't we use Spark in when we have less amount of data?
You can, but do you want to spend more money?
No.
Exactly. All right. The more resource you're using, the more money you have to spend.
Yes.
Correct. So
Yes.
why do we want to do that? We'll use pandas.
But it is more efficient, sir, when it compared to Pandas.
Correct. Efficient, but you also have to think about money, no?
Yeah.
Correct. So let's say I'm spending $10 to transform data on pandas, and I'm spending $100 to transform data on PySpark. But the time difference is only about some seconds. What will you use?
You go for Pandas.
There you go. That's it. Got it?
Yes.
Sir,
Yeah.
what are the difference between cluster mode and client mode?
I told you, right? Cluster mode is where you're using a collection of machines. Client mode is where driver program is working separately on a local machine, on a single machine, and the rest of the workers are working on a cluster of
Yes,
machines.
sir.
Okay, here both driver and the workers are working on a cluster of machines.
Okay. Got it.
Got it?
Yes.
Sir, could you please share this PPT on group?
Yes, it is my working PPT, but I'll share it to you guys. Okay.
Okay, sir. Thank you.
All right, guys.
Thank you, sir.
That's about it. Thank you so
Thank you,
much.
sir.
Thank you, sir. Thank you
Thank
so
you,
much.
sir. Good night.
Thank you, sir.
Thank you, sir.
Good night, sir.
Thank you, sir.
Thank you, sir.
Good night.